Hello once again, and let's get back to solving circle theorem problems. We have this question from worksheet 28, question number 7. And if we have a look at the shape, as we always do, we should think of the first angle that you can find based on the given angles. As for myself, I'm thinking of this isosceles. How do I know that it's an isosceles? Because from O to R, it's a radius. From O to D, it's a radius as well, which makes this side equal to this side. So accordingly, I will say step number 1, isosceles COD, where OC is equal to OD, because they both represent the radius of this circle. Accordingly, angle CDO is equal to angle DCO, and they're both equal to 180 minus 162, which is the given angle here, divided by 2, and this will bring these two angles to 9 degrees. So this angle here is 9, and this angle here is 9 degrees as well. Okay. Okay. Number 2. What I would be thinking of if I look at the shape is okay. This is a tangent. And this is a chord. The angle between the tangent and the chord is 42. Angle ACD is opposite to chord AD, or is facing chord AD, and it is a circumference angle. So this big angle here is equal to 42 degrees. Okay? So we're going to write what we just said. Angle ACD is equal to angle ADE, and they're both equal to 42 degrees. Accordingly, I can find this small angle here, right? So in this step, I will say that angle ACO is equal to 42 minus 9, and this angle will be 33 degrees. So we're talking about this angle here. It's 33 degrees. Okay? All right. Third thing I would be thinking of is tangent EF and radius OD are perpendicular. So step number 3, which makes this angle here equal to 90 degrees. Okay, so OD, radius OD, and tangent EF are perpendicular. Accordingly, we can find from this step angle. So without naming it as CDF, it's already named as Y. So we're going to say that angle Y is equal to 90 minus 9, and it's equal to 81 degrees. So this angle here is equal to 81 degrees. And immediately, I will move to finding this angle here. So step number 4, and is on a straight line, right? So we're going to say, okay, I think I need more space. Okay, let's say here angle. So this is step number 4, angle ADO is equal to 180 minus all the given angles, 42, 9, and 81, minus 42 plus 9 plus 81, and this will bring the angle down to 48 degrees. So this angle here is 48 degrees. And the reason is angles on a straight line. All right. So step number 5. We keep looking at the shape, and I will be thinking of circumference angle DAC, which is X, and center angle or angle at the center DOC. So step number 5, we're going to say that angle X is equal to half of the angle at the center, which is 162. And accordingly, the answer here will be 81 degrees. So this one is equal to 81 degrees. Last thing I would be thinking of, in order to finalize this question, I will be thinking of quadrilateral A, B, C, D, E. As you can see, it has 4 sides. All the points are on the center. All the points in this quadrilateral are on the circumference of that circle, which makes it a cyclic quadrilateral. And I will say step number 6, cyclic quad, and I would like to name it A, B, C, D. We can find angle Z, which is equal to angle Z is opposite in the cyclic quadrilateral to this angle here, which is composed of the 48 and the 9. So it will be every 2 opposite angles in a cyclic quadrilateral, the addition of 2 opposite angles in a cyclic quadrilateral is equal to 180. So 180 minus 48 plus 9, this will bring the angle down to 123 degrees. So Z is equal to 123 degrees. And so I think we found all the angles here, X, Y, and Z. We can go down here to to answer the questions basically. So X is equal to 81. And if you remember the reason, we said that 81 degrees, we said that X is equal to half of the angle at the center. The size of the angle at the circumference is half the size of the angle at the center. Okay, let's get back to y. Y is equal to 81 because OD, radius OD, and tangent EF are perpendicular. So here, it's 81 degrees because radius OD and tangent EF are perpendicular, and if you subtract angle 9 degrees in the isosceles triangle from 90 degrees, you will find the size of angle Y. Okay, and at last, angle Z, it's the opposite angle to 48 and 9. It's the opposite angle to the angle that is formed from 48 and 9 in cyclic quadrilateral ABCD. So Z is equal to 123. So Z is 123. Z is the opposite angle to 48 plus 9 in the cyclic quadrilateral named A, B, C, D. And accordingly, Z is equal to 180 minus 48 plus 9 because opposite angles in a cyclic quadrilateral add up to 180 degrees. And so it will be equal to 123 degrees. And we came to the end of this record. This is a very rich question where we applied mostly all rules of finding missing angles in circles. So I highly recommend that you watch this record multiple times or as many times as you need to until you nail all the rules of finding missing angles in circles. Thank you so much for watching, and I will see you in the next record sometime soon. Bye bye.